All right, here in example 1 is an example of a case 3 rational function. So it's case 3 because the degree of the top one is less than the degree of the bottom one. So this one here, we'll classify this as a case 3. And okay, so the degree here is 1, and that's a degree 2, so it's low over high. And basically what that says is that your horizontal asymptote is equal to 0. So I'm going to put that there. All right. So with everything, we're going to go to that step. Our first step is to determine whether it's simple or not simple. So that's step 0. It's not simple because there's a variable at top. Okay, and then the next step is the horizontal asymptote, in which case it's case 3. Horizontal asymptote is equal to 0. Our next step is to factor everything. Step 2 is factor it all out. So we'll go ahead and do that. Nothing we can do at the top. It's already a first degree binomial. But the bottom part does factor into x minus 2 and x minus 4. Okay. Step 3, we want to see if there's any holes in the rational function, and there are, and that's basically where the numerator cancels out with something in the denominator. And where it cancels out, that is where the holes are. So in this case, hole is equal to opposite the number, which is 2. Okay. All right, so the next thing we're going to do is vertical asymptotes, and that is 1, x equals negative 4. So this leftover 1, vertical asymptotes only happen in the denominator. So that's going to be x equals a positive 4. Okay, remember we changed the sign very much like h in the simple rational functions. Okay, in this one, x-intercepts, as far as having x-intercepts, there aren't any because we have a horizontal asymptote through 0, y equals 0, which is the x-axis. So the function can't intersect any of those x's, so there are no x-intercepts. Okay, as far as the domain, it can span across the x-axis, so such that x cannot equal whatever our vertical asymptote is and our hole. So it can't equal 2 and it can't equal 4 because of the hole and the vertical asymptote. Okay, as far as our range, y such that y cannot equal whatever our horizontal asymptote, in this case is 0, is there.